Today we're going to continue to talk about absolute value, and in fact, we're actually going to continue with writing equations of absolute value given a vertex. So that sounds pretty familiar, but you're going to find out the new part is also given a point. So we're going to write an equation with a vertex, but also a point. Now, what I want you to realize is that everything still goes back to our formula, our model for absolute value, the y equals a, the absolute value of x plus or minus h plus or minus k. So let's dig in. How are we going to come up with an equation that has a vertex at 4, 1, but passes through a point of 7, 5? Well, we'll start with the vertex, just like we always have, and this hasn't changed now for a number of days. Noticing that the vertex at 4, 1, you would say the graph shifted to the right. And of course, if you shift to the right, you do use a minus sign. And it also shifted up 1. So I plugged in my vertex, kind of like I always have, for h and k. So what about this point right here, this point of 7, 5? Well, what I want you guys to begin to understand is that that actually just represents an x and a y. Now, when we say it represents an x and a y, we really mean it represents an x and a y in this equation. And so algebra would say that we can plug in. We can plug in 7, 5 for x and y. Now be careful, because it's actually y that equals 5. So notice we're kind of using that number first, and then it's x that equals 7. So I'm plugging in 7 and 5 for x and y. Now notice that I still have my vertex plugged in, but now notice that I have the ability to solve this equation. And look what I'm going to be solving for. That's right, I'm going to be solving for a. Now you're going to learn in a couple minutes through this lesson that that's actually the goal of these problems, to find a. So let's pretend, let's not pretend, but let's actually solve this equation. I see some stuff that we can do on the inside. You always deal with the inside numbers first. So go ahead and actually subtract those numbers. Of course, 7 minus 4 is 3. But it's technically the absolute value of 3. So I want to keep those absolute value symbols there, because that's actually the next thing I'm going to do. Yeah, I'm going to actually do the absolute value of 3. Now, the absolute value of 3, yeah, it's still equal to 3, but it's important that you process that you actually have to do the absolute value as part of your solving. I'm going to write it as 3a. It just is a little more natural to write than a3. Okay, again, you see what's going on here. We're solving this equation for a. So, of course, you're going to subtract 1, and that's going to give you 4, and of course, you're going to divide by 3. Now, be careful. When you divide by 3, it's 4 over 3. A equals 4 over 3. Now, why is that so special? Well, that becomes the last part of this equation that I was looking for. That's right, I was looking for the a value. And so now I can actually record my full equation. I can record my full or final answer as y equals 4/3, the absolute value of x. Now look, it's still minus 4, and it's still plus 1. Okay, so I still need the vertex in there for my final answer. Notice I did not plug in 7 and 5 again. That'd be kind of strange to put those numbers in for x and y. I need to have the x and the y as part of the final equation. So what just happened here? What just happened? Well, I came up with an equation that was supposed to have a vertex of 4, 1. So that means that if I graph my equation and start at that vertex of 4, 1, and then use my slope of 4 over 3. Now, what do I mean use the slope of 4 over 3? Well, that should mean that I should be able to rise 4 and run 3 and end up with a new point. I should be able to rise 4 again if I want and run 3, and again end up with another point. Now, of course, you need to do that backwards so that you end up with the V shape that we always look for. So what's so special about this? Why are we making a graph? I thought we were trying to write an equation. Well, remember, I was trying to write an equation that passed through the 0.75. And if I look very carefully, it turns out that indeed it does. My graph does pass through 7.5. Well, that's the way it was designed. That was the way it was designed when we found an a value of 4/3. We're writing an equation given a vertex and a point. But when it comes down to it, what we're actually trying to do is find the correct a value. And of course, that correct a value is going to give us the slope that will lead us to the point, in this case, the 0.75. It might be helpful if we sort of record the steps that we followed here. So I'm going to go ahead and use this space to do that. You're welcome to also take these same notes. I just want you to realize that we really went through 4 steps. Plug in the vertex. That was the first thing we did, right? Now you also plugged in the point. Notice though that really is 2 steps. So we want to be careful that the vertex goes in for h and k, and then the point goes in for x and y. Now perhaps the key thing here, the main thing, was so that we could solve for a. That's really what you're trying to do. You're trying to find the a value so that you can write the equation. So probably not a bad idea to record those 4 steps. That way you have them when you're ready to try. All right, now listen, if you're watching this video, you're probably not in class or you weren't here for class, but you really want to try this problem, okay? You want to actually see if you can do the steps to write this equation. So go ahead, start with the vertex. You should be filling that in for h and k. Remember now, the number on the inside is the opposite, so if I shift it to the left, I actually do need to use a plus sign, +3. It's also going to be +4. Plug in the point. Remember, that gets plugged in for x and y. Make sure y goes in for y and x goes in for x. Now at this point, you're actually solving the equation. Do you want to kind of do the right order? 1 + 3, the absolute value of 1 + 3, that's the next thing on the docket here. You want to actually add those numbers. Now you get 4, but technically it's the absolute value of 4. Okay, you want to actually do the absolute value. Now the absolute value of 4 is still 4. Okay, but now officially I have -4 equaling 4a + 4. Lots of 4's in this problem. Careful as you keep solving. You should be subtracting 4 and then dividing by 4. You're writing an equation, so you want to make sure that you actually record that final answer it's always going to involve that y equals. Now we know that the a value is -2. Okay, keep the x. It still has a vertex of -3, 4, so I'm going to keep the +3 and the +4. Feel like you're getting the idea? Now, Algebra 2, as we journey through Algebra 2, you'll discover there's oftentimes different ways to do one problem. And I want you, as we go through the whole year, to understand the multiple methods. And it's not good enough just to be able to do it one way. So we actually have our first encounter where there's really two ways that you could write an equation for this graph. Now, one of the ways you really learned in the last week or so. So do you realize that you can just look at this graph and you can basically come up with the important components? Perhaps still the most important component is this vertex. Okay, now that vertex is going to be at 3, 4. And of course, once I have that vertex, I'll be able to fill that in for h and k. But do you realize that you can find the slope? Like right now, you can find the slope. All you have to do is have another point so that you can count basically the rise and the run. I'm pretty sure I'm going to rise -1, and I'm going to run 2. So we would say that that means that there's a slope of -1 over 2. Now, how did I do that? I basically found another point, and I just counted from the vertex to that point, rise over run. Now, listen, that is supposed to be pretty easy. Yeah, if you have a graph, it's pretty easy to be able to see the vertex and to see the slope. Just fill those numbers in your equation, and mission accomplished. You've got your equation written. Okay, but I would like you to be able to 100% process this second method. And so why don't we try to find a point? Do you realize that what's happening here is we're using some point that's on the line? Now, why would I go way over here to -5, 0? Well, honestly, it kind of jumped out at me. I'm also like 100% sure that that's -5, 0. But if you're asking, you could have used any point. You could have used any point that's on the graph. I'm just going to choose to use -5, 0. Okay, now when you plug in, right, when you plug in, you're going to be plugging your point in for x and y. You're going to be plugging your, let's finish plugging in the point. Okay, so I plug that in for x and y. You're also going to be plugging in your vertex for h and k. Do you see here that I am not plugging in for the letter A? Okay, technically it's like I'm trying to find the letter A. Okay, so let's solve. Yeah, I skipped a step, and I give you permission to, if you understand, to jump right into this step where you're plugging everything in for the vertex and for x and y. Again, I give you permission to do that if you understand it. Okay, either way, make sure you're doing -5 minus 3 first. That comes out to -8. Now, be careful. It's not going to stay as -8 because you have to do the absolute value. Yes, you have to do the absolute value of -8, and that'll actually change it to +8. All right, I'm still solving for A. I'm going to subtract 4 and divide by 8. Now, when you divide by 8, be careful. Yeah, you end up with a fraction. -4 over 8, that's the same as -1/2. I've seen -1/2 before. Yeah, it's the slope. It's the slope that I found from the graph. It's supposed to work that way, okay? Yeah, it's supposed to be the same answer. But we want to be able to do the method. We want to be able to solve for A. And now you know how to write an equation given a vertex and a point.